Hello all. Today's session is going to be on data center virtualization. So we're going to talk about virtualization and the various types of virtualization that we can find in a data center. We'll start off looking at server virtualization, which is where the concepts associated with virtualization kind of originated. And we'll see how it evolved out of traditional data center architecture. We'll also talk a little bit about containers. Next, we'll talk about storage virtualization, or software-defined storage, as it is sometimes called, SDS for short, as well as network virtualization and virtual NICs. We'll also talk about cloud computing and converged or hyper-converged infrastructure and how this ties into virtualization. And then lastly, we'll review some of the services and trainings related to virtualization that are offered through Ingram. With today's high-speed memory and networks, fast storage available in the form of SSDs and NVMe, and the high frequency and core count of today's modern processors, each modern computer is packed with more speed and bandwidth than ever before. The downside of this is that most computers spend a great deal of time just waiting for humans to do something. If you do a Control-Alt-Delete on your system and bring up Task Manager, you'll see that your CPU is usually around 15% busy at any given time. Server virtualization gives us a way of reclaiming that lost CPU bandwidth without having to worry about potential software conflicts when we run a lot of applications. Server virtualization is intended as a solution for situations where underutilized servers waste power, multiple servers running single applications increase maintenance costs, and we need robust disaster recovery or business continuity solutions. Before we go into how server virtualization actually works, let's take a look at traditional server architecture to have a point of reference to build off of. In the past, many companies used to put all of their applications on a single server, as long as the server had enough memory and storage space to satisfy all the applications being installed. Sometimes a conflict in the way software was written would cause one or more applications to crash when forced to share resources like processor or memory. The same thing still occasionally happens with desktops or notebooks. Usually, closing certain applications or rebooting your system will fix it on a desktop or notebook, but those options may not be convenient to perform on a server supporting hundreds or thousands of users. The easy solution in the server world was to put separate applications on physically separate servers so they don't conflict with one another. Instead of just the server, we now had the email server, the database server, the file server, etc. Unfortunately, that means more hardware, but with less utilization per server. Customers ended up buying more hardware, but essentially we're using less of it. Server virtualization is a way of running multiple applications on the same piece of hardware, but in an isolated resource space so they don't cause conflicts with one another. In traditional architecture, we have physical servers running server operating systems, such as Windows Server or Linux, on top of the hardware, with your applications and their associated data sitting on top of the operating system. With server virtualization, the operating system we install on top of the hardware is called a hypervisor. A hypervisor allows multiple operating systems to be installed on top of it, just like you can install multiple applications on top of a regular operating system. Using the hypervisor, individual operating systems, their associated applications, and the application data are bundled together into a single file called a virtual machine, or VM, which runs in its own isolated space on the server. As is shown in the diagram, you can have many virtual machines on a single physical server. I put definitions of these key terms on a separate slide, so if you want to look at the presentation later, you'll have them all in one place for reference. When talking about server virtualization, the term guest is used to refer to the other operating systems that are installed on top of the hypervisor. All the VMs on a single physical server or host running a hypervisor do not have the same operating system. Each virtual machine has its own operating system as part of the VM. So I could run several different versions of Windows and Linux simultaneously, all on the same host if I wish. One of the convenient things for management of virtual server environment is that all the info that makes up a guest virtual machine, all the operating system, the applications it contains, and all the data files it contains as well, appear as just one single file to the hypervisor, making it easy to back up, copy, or move. If I run 20 virtual machines on a single physical host, at the hypervisor level, those 20 full servers each appear as only a single file. The 5 main hypervisor products for server virtualization that are available today are VMware vSphere, Microsoft Hyper-V, which is included in Windows Server, Red Hat Virtualization, which is built on top of a product called Kernel-Based Virtual Machines, or KVM, Nutanix Acropolis, and Citrix Hypervisor, formerly known as Citrix Zen Server. So now that we have a basic understanding of how virtual machines work, by packaging together a guest operating system, any associated applications, and any data, binaries, or libraries needed for everything to function together into a single packaged VM, let's take a look at another type of server virtualization called containers. Unlike virtual machines, or VMs, containers don't use a hypervisor and run a single operating system just like a traditional server would. The difference is that on top of the operating system, they run an application called a container engine, which allows applications and their associated data files to be packaged together into containers that each run in their own isolated resource space on top of the operating system. A container is kind of like a virtual machine, but without a guest operating system packaged into it. The advantage of containers is that I don't use up resources for a hypervisor and multiple occurrences of guest operating systems. The disadvantage of containers is that all my containers must run on top of the same operating system. Docker, Kubernetes, and HPE Ezmeral are all applications used in running containers. I grabbed this slide from somewhere years ago and thought it was a pretty good reference for why someone would use server virtualization. It holds up pretty well. Most of these still apply to virtual machines or containers. By running multiple applications on the same physical host, virtualization allows you to consolidate your infrastructure into fewer servers. The second point on here, infrastructure provisioning. It allows you to provision or add and create virtual machines on the fly, making a functional server get up and running much quicker than if you were to go out and buy one from scratch. Business continuity. When using server virtualization with shared storage, it's easy to swap the server ownership of a single virtual machine. Remember, it's just a single file. And that way I can switch data to another physical server in case of maintenance or unplanned downtime of a physical host. Testing and development. For purposes of testing and development, like writing new software products or generating revisions, it's easy to create new virtual machines for test environments rather than have to set up entirely new servers each time you want to run a test. The last two on here probably apply more to VMs than they do containers, but enterprise desktops, rather than give everyone in an office environment their own PC or notebook and then have to have IT responsible for managing and supporting those hundreds or thousands of systems, you can create virtual desktop images on a server and push them out to terminals or thin clients. That way, you only need to manage one piece of hardware, the host server. Legacy application rehosting. Some business critical applications are written for outdated operating systems. We have one in-house that was written years ago for Windows NT around 1998. With virtual machines, I can put whatever operating system I want inside a virtual machine, and it doesn't even have to be compatible with the hardware I'm running. The hypervisor does all the translation for the actual hardware for me, so I can keep those special applications running much longer than I normally would. Moving from server virtualization to storage virtualization, or software-defined storage, SDS, virtual storage allows us to repackage storage and present it differently to users on the network. SDS is usually used to combine storage from multiple sources and present it as shared storage to users on the network. Depending on the software used, SDS can present data as NAS or SAN storage. It can be a way of combining storage to make it more useful, but it can be lower performing than a true traditional SAN. Ingram sells SDS solutions through many vendors. HPE Complete is a program where HPE resells software solutions from other vendors just to make them easily available to their hardware customers. This is a very basic example of how many SDS solutions work. In this example, each of the 10 servers across the top has 1 terabyte of usable storage inside of them. When each server has SDS software installed on them, they find each other on the network, form a cluster, and they can present a single 10 terabyte volume for use on the network, although it really consists of 10 separate 1 terabyte chunks on 10 different servers. Virtual networking, or VNICs, allow multiple virtual network ports to be combined with their signals going out over a single physical network port. Said another way, virtual NICs allow a physical NIC's bandwidth to be broken down into multiple virtual NICs of slower speed. These are some of the different uses for NICs on a server. Many of them, such as management or cluster heartbeats, don't use a lot of bandwidth, and they might not need the full bandwidth available through a NIC port dedicated to them. Virtual NICs are sometimes, but not always, found as a feature on 10 gig or faster NICs. Emulex, HPE, IBM, and Lenovo all offer products that support virtual NICs. Cloud, converged, and hyperconverged are all popular terms in the industry nowadays. Let's look at what it takes to create an on-prem cloud or a hyperconverged solution in terms of what we learned about virtualization today. First of all, we need server and compute resources, and a lot of them. So we'll be looking at rack mounts or blades to be our host servers. For storing our data, we'd want either a shared storage solution like a SAN or some sort of software-defined storage that all our server nodes can connect to. Virtualized NICs allow us to carve up network bandwidth according to the bandwidth requirements of the individual connections we need created. A hypervisor installed on our servers allows us to divide compute resources and create virtual machines as needed on the fly. Virtualization of our compute, storage, and networking resources lets us provision any kind of server we want at any time. Included software tools and templates allow us to create virtual servers of any combination of resources we want instantly and deploy them to our network in seconds to minutes rather than hours to days. Virtualization of our system resources allows an end user to acquire server resources, not knowing exactly what they will need in the future, and carve them up however they need instantly. When a project is completed, no longer needed resources can be released back into the pool of virtualized resources to be assigned to another project in the future. One example of this is Roswell Park Cancer Institute in Western New York. Does a lot of research on different forms of cancer. Every time they receive a grant for a new study, they're going to need new computer resources that go along with that. So they will need to have new servers ordered, brought up to speed, operating systems installed, etc. What they did several years ago was set up their own on-premise cloud. So they essentially had pools of processors, memory, NICs, and storage ready to go. So every time they got a new research contract for a new department, they could essentially provision and carve off any of the resources they needed for the project into a new virtual server, rather than go out and go shopping for servers and wait a couple of weeks for the turnaround of the server to actually come in, have somebody install software on it, etc. So maybe takes several weeks to over a month to get a new server set up. With an on-prem cloud and provisionable resources, they could do this in a matter of minutes from the resources they already had on hand. The very bottom here, these are virtualized, converged, or HCI solutions available through Ingram Micro that allow for the full on-prem cloud experience for those looking to reduce deployment times for new hardware. The Cisco HyperFlex, Cisco and IBM VersaStack, IBM PureFlex, and the HPE SimpliVity, HPE Nimble DHCI, and Nutanix solutions. When it comes to services and training related to virtualization, Ingram Micro's professional services team can be a one-stop resource. Professional services offers a virtualization health check for customers looking to get into server virtualization. Professional services will run an assessment of the end user's current environment and make recommendations on the number and specifications of servers that they can consolidate and migrate to. Ingram Micro also offers training services from several different vendors on virtualization. So any end users looking to learn more, we have several different solutions to offer them. That brings us to the end of our presentation. I hope you find that useful. Thanks for attending.